Thank you for joining us. I'm Tom DeRosa, the Executive Director of Creation Studies Institute. We're standing right now in the Creation Discovery Museum. It's part of Creation Studies Institute's outreach. And right now I'm at a dinosaur called Coelophysis, section under Catastrophe. You'll notice that this is a beautiful casting. It's a replica made similar to the one in New York City, American Museum of Natural History. Now, if you take a look at this, this is a marvelous display of a dinosaur that met its demise by a quick flash flood. Now, not only did this dinosaur, Coelophysis, die, but we found many others like it dying because of a flash flood. Thousands of bodies have been found. This is one of the most prolific sites. It's found in Ghost Ranch, found in New Mexico. And so what we see is kind of a reptilian creature, dinosaur, and we see that its marvelous claws, its legs, prominent legs, it'd be about 3 to 9 feet in length. Inside of it, we can see that in the side of the stomach, we can actually see its contents. There are bones, we believe, of a crocodile. So not only do we see quick burial, we also see the contents of a stomach instantaneously recorded. So it's like somebody taking a picture, and there it is. This is a great example of catastrophe. In our catastrophe area, in our museum, we have a beautiful picture, fossil, of a buried fish. This fish comes from the Green River Formation. It is a river that exists today, the Green River, that extends 730 miles. In this area, there are 3 basins that intersect. It's in the western part of the United States. We have Wyoming, southwest Wyoming, a tributary basin, comes down to Utah and Colorado. In that area, we have many, many different kinds of fossils, including these fish fossils. This is in the lower part of Wyoming, and we literally have a lake. And that lake has produced some beautiful, beautiful fossil fish. Now, evolutionists like to say that this fish is millions of years old. They like to look at the layers. There's little layers here, little barbs that you can see, sediment that seem to be in layering, covering the fish, around the fish. Inside, you can actually see the beautiful, exquisite detail of water just being moved back and forth. So they believe that this fish died on the bottom for some odd reason, because we know when fish die, what do? They float up. This fish is found on the bottom. As creationists, we believe there was a worldwide flood. This flood would make the mechanism for this fish to be pushed down to the bottom and then piled up quickly. And as the waters were going back and forth, it left these beautiful, beautiful shale formations of the layering. Therefore, this fish died out from a catastrophe, not millions and millions of years of layering and layering and layering. This is a great example with all its beautiful detail, including the vertebrae that can be seen. You can see the fins. It's beautiful. They even have fish eating fish in this area. This is a great example of catastrophe. Hi. We're now in the Creation Discovery Museum, Creation Studies Institute's outreach. And in this section, the catastrophe section, I have a fish sandwich. You might be wondering, what is a fish sandwich? Well, it's a stone fish sandwich. It's not a real fish sandwich. It's stone. It's made of stone. Inside the stone, you can see that there's a fish. There are millions of these fossils in the Oard Basin, located in northeastern Brazil. There are so many of these fossils. It showed us that something happened catastrophic in nature. This is off the rift of Brazil, where the ocean meets the continent. There are so many of these fossils, and they are known for their exquisite design. We have many of them. They were donated by Joe Novello, who made many trips to Brazil, and now we have these beautiful fossils that we're going to be willing to show everybody that spells out definite catastrophe. Hi, we're in the catastrophe section of the Creation Discovery Museum, sponsored by Creation Studies Institute. I now have a bipedal dinosaur. And when you look at it, you can see that this footprint is impressive. Now, we have many dinosaur footprints throughout the world, many thousands of them. And what we've noticed is that they all go in a straight line. What we also notice that footprints in particular, dinosaur footprints, seem to have been put on different layers of the Earth. In other words, when we look at layering of rocks like this, the dinosaur walks on one layer. And then after supposedly a period of time, there's another layer, another layer, another layer. And what we have found is that we found footprints of the same dinosaur on all these layers, supposedly in evolutionary time taking millions of years. Now, there's something wrong with that idea. The problem is that why are we finding the same dinosaur footprints in this different layers? And the answer is because we had a worldwide flood. And what happened was, as the waters moved back and forth, dinosaurs were moving and escaping up north, up to the upper elevations. And we would find these dinosaur prints moving up in those areas. We've seen these dinosaur footprints all over, representing that there was a catastrophe.
Okay, there we go. Based on the Bible, Taz Walker divided the flood up into two stages: flooding stage where the water rises and a retreating stage. During the retreating stage, the continents come up out of the floodwaters as the ocean basins sink. And we have a lot of evidence of this, what I call differential vertical tectonics, where part goes up and part goes down. So during the flooding stage, that's the time when we collected a huge amount of sedimentary rocks, an average of about 6,000 feet on the continents. Actually, at the peak of the flood, you probably had about 2,000 more feet that's not here, because during the retreating stage, we had a lot of erosion that occurred. About 2,000 feet worth, leaving 6,000 feet still on the continents. So I'm going to pick a few things to show the flood that there's really abundant evidence for the flood, especially if we open our minds to what to look for. So a good place to see the deposition of sediments is Grand Canyon. You'll notice a few things here. We have layers. These layers supposedly were laid down in 250 million years according to the uniformitarian time scale, and the top is flat. And that flat top is a planation surface after about 10, 12,000 feet of erosion of the whole area. We know this because north of Grand Canyon area, in Utah, you have the Grand Staircase. And that sedimentary rock dipping to the north, 3 to 5 degrees, used to be up over Grand Canyon. And it all got eroded as a monstrous sheet of sediment, leaving a flat surface. Then the canyon was cut by more channelized flow. But I'm getting ahead of myself. The sediments themselves were laid down in the flooding stage. And there's several features in here. Now, the alternative model to explain all this is uniformitarianism, slow processes over millions of years. Processes like we see along a river flood, deposits sediment, but usually deposits small-scale sediment, sedimentary packages. It'll change rapidly from conglomerate to sand, to silt, to clay. It's quite a mixture both vertically and horizontally. But when you look at the Grand Canyon and other sedimentary rocks in the world, you don't find anything close to that. And Grand Canyon is a good place to start. At the bottom down here, we have the Tepete sandstone. And that sandstone you can trace over 200 miles in the canyon. It's pretty even, about 100 to 300 feet of sand. And it's on a unique place in the earth. It's on the upper crust, mostly the granites and metamorphic rocks. So we can check the upper crust and what's above the upper crust from other places in North America. And we find that same sand layer. It's given different names in different states because the geologists didn't know they were connected, and they just gave them different names. So this Tapete sandstone, which looks like that on the bottom of the Grand Canyon, it's a coarse-grained sandstone, has these little cross beds. You can see some of the quartz grain. Everyone see my cursor?
Mhm.
Okay, it's coarse-grained, and we can trace that up into my area. In Montana and Wyoming, it's called the Flathead Sandstone. This is the same sandstone up near Cody, Wyoming, that sits on the granite of the upper crust. And we can trace that sand on the upper crust over half of North America. In fact, it continues up into Canada through the Western Rockies up into northeast Canada, mostly in the subsurface. And it covers half of North America. Now I ask you, what present processes, that's what they rely on to explain all the past rocks and the fossils in them, what present process would explain a sheet of sand 100 to 300 feet thick spread over half of North America? There's nothing in present day processes that even come anywhere near that. This is evidence of a gigantic catastrophe, Noah's flood, that spread layers over huge areas when it deposited. Also, when we look in Grand Canyon, we see this 250 million year sequence, one layer flat upon another with little or no erosion. And when you consider that erosion over a million-year time scale is huge, we should see canyons and valleys in those walls of the Grand Canyon. They're not there. This indicates rapid deposition, one layer upon another in quick succession. Erosion over a million years time scale, like I said, is rapid. All continents could be eroded to sea level in 10 million years at today's rate. And there's some caveats to that. That's a minimum. But you can put a maximum of 50 million years. So in 10 to 50 million years, all the mountains and everything should be eroded to sea level on all the continents. That's how fast erosion is. So therefore, we should see canyons and valleys easily in that 250 million year sequence that they claim for Grand Canyon. And here's how it would go. Let's say this is just 500,000 year sequence. 4 layers are suddenly laid on the granite of the upper crust, and then give it 50,000 years, and you're going to erode part of it, forming valleys and canyons. And then you have another deposition event, and it fills up the valleys and canyons, and it happens again. That's what you should see on the walls of Grand Canyon if it was just laid down in 500,000. Not to speak of 250 million, because it would be totally wiped out about 25 times. So this is what you commonly see. Generally, the layers are even for the whole distance of the Grand Canyon, to about 200 miles. Some layers will thin and thicken. So that's what we see. And it's interesting, this is a photograph of the Teton Mountains in northwest Wyoming. The Teton Mountains are where the granite upper crust came up, and it eroded in the middle and formed those nice sharp peaks of the Grand Tetons. But on the north and south, the sedimentary rocks were not eroded off. So right here, you're seeing the southern part of the Grand Tetons. Represents 2/3 of the bottom of the Grand Canyon, but we're about 1,000 kilometers to the north. Very similar sequence right in here. And it's one layer after another laid on top of another. And 3 geologists even admitted that in this book, A Geological Chronicle, Jackson Hole and the Teton Range. The regularity and parallelism of the layers in well-exposed sections suggest that all these rocks were deposited in what? A single uninterrupted sequence. Do they believe it? No. However, the fossils and regional distributions, etc., means that it was deposited over 200 million years, they claim. They don't believe their eyes, their observations. Observations is science. So they go to their theory, their ideas on deep time and evolution, and they pigeonhole all that sediment like this. Here's the real layers in the blue, and there's missing sedimentary rocks between the Bighorn Dolomite and the Darby Formation. You have 80 million years missing. Where's all the erosion in all that time? It's not there. And also right in these formations, it looks like some of them were deposited over 10 million years, but no, a lot of times these formations are full of gaps, time gaps, which they don't show here. So only about 1% of the record in the sedimentary rocks of all that time exists. The rest is just empty space to them. They give it an excuse it was erosion or non-deposition. But regardless, their eyes indicate it's one uninterrupted sequence. I'm going to skip this. This is commonly what we see, graveyards. Now up here in Montana and Alberta, we have some huge dinosaur graveyards. This is a graveyard in Venezuela of ammonite fossils, all bunched together. We have a graveyard north of here that has 10,000 duckbill dinosaurs in an area about 2 miles by 1 mile by 3 feet tall, about 10,000 of them, all of the same species, which is really interesting. What would cause that? Well, they wing it a really big catastrophic flood, flash flood, local flood, they believe. But this fits with the biblical flood. Lots of evidence for the flood. And then in Alberta, there's a dinosaur graveyard of Champsosaur ceratopsians, and they estimate well over 10,000 of them in this one area in Dinosaur National Park up there. And then we have a huge amount of dinosaur fossils in the Glendive area, where we have another museum. And then here's one of these fish-eating fish that Tom mentioned. This is from the Green River Formation, which is a flood deposit. And we have evidence of an ichthyosaur giving birth and being buried and fossilized, rapid fossilization. And when we look at 95% of fossils are marine shelled organisms, and many of these, if not most, are closed-shelled all over the world, indicating that they were rapidly buried and as a result, rapidly fossilized all over the world. It's a global flood. Lots of evidence for the flood. We need to open our minds to this. Now I'm going to go into a few evidence for from geomorphology. Geomorphology is a study of the surface shape of the Earth. During the retreating stage of the flood, you had massive erosion, and this erosion marked the land, the surface of the continents, with unique features that secular scientists can't explain. There's a big number of them, but I'm only going to emphasize a few with the short time I have. And we're talking about the retreating stage, when you had massive erosion, an average maybe 2,000 feet of sediment washed off the continent, cleaning off the continent and deposited where the water was slow, hitting the deep water of the current oceans and forming the continental shelf and slope. That's where the sediment from the erosion ended up. I'm going to skip that. I'm going to talk about planation surface. I showed you one. The top of Grand Canyon is a big planation surface. First of all, we'll define an erosion surface from the Dictionary of Geological Terms. It's a land surface shaped and subdued by the action of erosion, especially by running water. The term is generally applied to a level or nearly level surface. If it's a little rolling, it's an erosion surface. If it's plain flat, it's a planation surface. And we see these features on all the continents, and I'll get into the significance of that, but let's take a look at one. This is in the northern Bighorn Basin in north central Wyoming. You can see the sedimentary rocks dipping to the west. I'm viewing south at various angles, and something sheared it off at the same angle, both hard and soft rocks. And there's about 15 feet of rounded rocks on there, showing that water eroded this. And where I'm standing is a continuation of that planation surface, but in between, it's been eroded either by very late channelized erosion in the flood or post-flood erosion or both. See, these planation surfaces are broken up a lot of times, but you can connect the remnants and show how large they were at one time. So that's a planation surface there. And in my area of the world, here in northern Montana and southern Alberta, we have planation surfaces at 4 levels. This is the top level right here, the Cypress Hills, which used to be connected, but glacial rivers or late flood erosion dissected it. But this is a high flat plateau in Canada. Here's the Flaxville level, and these are erosional remnants, and they are all connected at one time until they got dissected. And they're all capped by rounded quartzite rocks. Quartzite is a metamorphic sandstone, and we know that they came from generally Idaho and extreme western Montana, and they're spread up to 800 miles to the northeast and east, up into central Saskatchewan and southwest Manitoba and western North Dakota. But let's take a look at this, and this is a rose diagram showing the direction that the gravel was coming from, west-southwest, or another one was southwest. And the nearest source for all this quartzite is central Idaho. And there's the planation surface of the northwest Cypress Hills. And there's a central part. There's the eastern part right there. When you drive up onto it, it's flat as a pancake. And here's the one at Grand Canyon I told you that was eroded. Here's the north rim of the Grand Canyon. And this is all big planation surface with 10 to 12,000 feet of erosion as a huge sheet, a chunk of sedimentary rock eroded in what they call the early Cenozoic, leaving this planation surface. Planation surfaces were much larger. I'm going to quote from Lester King. He's my favorite geomorphologist. He's a world traveler. He's examined these, documented them all over the world. He says a planation of extraordinary smoothness developed over enormous areas on the continents. From it, most of the world's present scenery has been subsequently been carved by renewed erosion. In other words, once the planation surface formed, they were lifted up or dropped or dissected, eroded, so you have a lot of remnants around. So, but they're once much more extensive. Here's one in north central Montana, east of what's called the Little Rocky Mountains. It's as flat as a pancake. To the left is they build an airport. It's being destroyed now by streams coming out of the Little Rocky Mountains. So what we observe on these planation surfaces today are they're being eroded. They're not forming. They don't form today. Totally against uniformitarianism, but great evidence for the reality of this monstrous catastrophe, the Genesis flood, mainly the runoff. And here's kind of a summary. If a slow process of erosion over millions of years is a uniformitarian idea, when we have tilted sedimentary rocks, which are generally alternate between hard and soft rocks, the hard rocks should remain as ridges, and the soft rocks erode more and partly fill up the valley left. That what we should see everywhere. We should see no planation surfaces anywhere. But this is what we commonly find. Both hard and soft rocks sheared off the same with rounded rocks, rounded from the action of water on top, indicating that water formed the present scenery of the Earth's surface and formed planation surfaces. Now, in your area of the eastern United States, the Piedmont area east of the Appalachians is one huge erosion surface. It's kind of rolling. It's got a few erosional remnants sticking up, but it's an erosion surface amounting to thousands of feet of erosion down to that level. And also when you go west of the Appalachians, you find the Allegheny and the Cumberland Plateaus. These are planation surfaces west of the Appalachian Mountains. So in summary, planation surfaces are not forming today, they're being destroyed. They were once much larger, common as erosional remnants. They're worldwide, not a local flood, a global flood. Difficult, if not impossible, to explain by slow processes over millions of years, the uniformitarian model. This is powerful evidence of a catastrophic runoff of the floodwaters. How much time do I have left?
You can go a few more minutes.
Okay. I'm going to talk about the quartzite rocks, a metamorphic sandstone. It's been heated up 500 degrees centigrade by deep burial and raised up in the mountains. And these quartzite rocks are very hard, one of the hardest rocks in the world. And when the erosion of the Rockies occurred during flood runoff, it pulverized all the other rocks because they're softer. But the quartzites took off as big chunks and rounded it and spread it, like I said, 800 miles from the source. Here's kind of the big picture. During wide currents, early in the retreating stage, eroding the rocks from mainly the western Rockies in Idaho and western Montana, spreading them out clear into Manitoba, central Saskatchewan, spread 800 miles from the source. What present processes of erosion are going to do that? None. And when the Continental Divide area came up, it split that flow to where you had now quartzite rocks being spread clear to the Pacific Ocean. I've been to many of these locations, hundreds of them in these areas of these rounded quartzite rocks, rounded by water. And here's the general area where we find them, in that area. And in the big green areas is where we find them in the area of Idaho, Montana, and Wyoming. And these green areas represent big cracks in the earth where the rounded quartzite rocks piled up. This one here is still 15,000 feet of these rocks piled up. And here in western Wyoming, northwest Wyoming, it's up to 11,000 feet. And here's the Teton Mountains. They're right up on the top of the Teton Mountains. I took a 3-day hike up there with Brent Carter, creation geologist from Boise, Idaho. And sure enough, on the top of one of the mountains on the northern Teton, on limestone formation, we found rounded quartzite rocks. There's the largest one I found. Notice how rounded and smooth it is from the action of water. And here's one on top of the Teton Mountains. They have these semicircular cracks called percussion marks. They're very common, indicating just torrential pounding. This can't be duplicated in today's world. Again, against uniformitarianism. And in Washington, we find huge concentrations of them a lot of times on the highest terrain. Of note is the Wallowa Mountains right in here. And we took and then Puget Sound area mixed with the glacial deposits, even up in around Vancouver, British Columbia. And the Wallowa Mountains are especially distinctive because we took a hike up there. There's supposed to be one a meter in diameter up there. We didn't find it. It's probably in that snowbank. We're at 8,200 feet near Lookout Mountain. And this is the largest one we found. Notice how rounded it is and polished. Spread about, came from 100 miles to the east, central Idaho, across Current Hills Canyon. And the flow was so strong that in this finer material, representing the softer rocks broken up, there's gold in there. In fact, they had an active placer gold mine on the top of the Wallowa Mountains until they made it a wilderness area and they had to close it down. Tremendous evidence of catastrophe. All these plateaus I showed you earlier are capped by rounded quartzites. And in this below the glacial material in southern Saskatchewan in this blue area are quartzite areas. Deposits come from the central Idaho, 800 miles from their source. Powerful evidence of catastrophe. And on the top of the Cypress Hills, it's capped by 75 feet of this rounded quartzite rocks from Idaho. And you can see it right here. The rounded rocks capping 75 feet worth. And there a lot of them are orange stained and they have percussion marks. There's a great example of percussion marks from the Cypress Hills. This is one of the hardest rocks in the world. Probably currents going 100 miles an hour with tremendous turbulence. So I think I'll leave it at that since my time is up and go back to you, Tom.
Very good. Very good. Enjoyed that. I look at that quartzite rock and say that you mentioned it being the hardest rock. So that tells you that this had to go through a lot of movement, and then all of a sudden it literally smooths out as it was been through a rock tumbler. Wow.
Right.
You see
Tremendous
water
evidence for catastrophe.
Right.